From their place in pop culture to their relevance in the real world, for decades, people have been wondering what exactly gamma rays are. Well, in short, these rays originate from what are known as gamma ray bursts, or GRBs in the scientific community, and they're the single most energetic bursts of light there are. In fact, these GRBs are so strong that they release more energy in a split second than our sun will release in its entire lifetime. So today, we're going to be diving right in and counting down the top 10 freaky facts about gamma ray bursts on this episode of Super Freaky Science. If you want to know about all our latest super freaky videos, don't forget to subscribe and hit the notification button. Gamma ray bursts are known to occur during an extremely powerful type of supernova known as a hypernova. These large explosions are about 5 to 10 times the size of our sun and are 100 times brighter than a regular supernova. Now, the sheer magnitude of these explosions are so powerful that a majority of them end up imploding and creating black holes. And since the only known creator of gamma ray bursts are hypernovas, the formation of black holes is therefore directly tied to gamma ray bursts. Although gamma ray bursts can be observed from Earth, they actually occur several million light years away from our planet. This is probably for the better. After all, the most powerful GRB ever detected, which was captured on April 27, 2013, lasted for several hours and emitted 94 million times more energy than that of regular visible light. In fact, these GRBs may even be the result of the largest types of stars collapsing in on themselves when the fuel within them reduces to a point where it is no longer able to sustain and support the star. Their resulting explosion is then so large that, be it an asteroid or a planet, they're able to disintegrate most celestial objects in their path. Therefore, it has been suggested that a part of the creation of the cosmos is linked to the gamma ray bursts found in hypernovas. However, that is yet to be proven. Gamma rays have quite a visual impact, despite the fact that they usually don't last more than a few seconds. That's because gamma ray bursts shine several hundred times brighter than supernovas, and about 1,000,000 trillion times brighter than our sun. Therefore, when a gamma ray burst occurs, it's briefly the brightest event in the cosmos, and it's in fact so bright that their wavelength on the color spectrum is invisible to humans. As a result, we guess you could say it's both the brightest and most invisible thing in our universe, depending on who you ask. Gamma ray bursts were first detected in 1967 by a fluke. You see, during that year, a satellite had been in service to monitor nuclear material. However, it accidentally picked up on non-nuclear activity, and this was kept on record. Then, in 1969, two scientists named Ray Lebezadel and Roy Olson were looking over the data from the 1967 detection and discovered that the non-nuclear activity detected was of cosmic origin. This led the pair of scientists to team up with colleague Ian Strong to do some further research in 1972. And by cross-referencing information from other satellites, they were able to definitively say that a phenomenon known as gamma ray bursts had been detected. Armed with this new information, NASA then began to focus on these events and soon initiated what came to be known as the SWIFT Gamma Ray Burst mission. There are two main types of gamma ray bursts: short duration bursts and long duration bursts. Short duration gamma ray bursts last anywhere from a few milliseconds to a maximum of 2 seconds, with the average coming in at about 0.3 seconds. These bursts are usually caused when either two neutron stars merge into a black hole, or when a neutron star and an existing black hole merge to create an even larger black hole. In contrast, long duration gamma ray bursts typically last anywhere from 2 seconds to several minutes, with some of the longest going on for several hours. However, they typically only last about 30 seconds. This type of gamma ray burst is closely related with supernovae and hypernovae, specifically the ones that result in the death of a star. Therefore, their connection to these higher impact events make them last longer than their shorter counterparts. In 2004, NASA launched a satellite with the specific purpose of detecting gamma ray bursts and sending information and data to Earth. The main instrument used on this satellite is called the Burst Alert Telescope, or BAT. This telescope's primary function is to detect gamma ray bursts quickly and effectively, calculate their position, send this information back to the spacecraft, and then eventually transmit this data back to Earth. Since the launch of this satellite, there have been about 1 gamma ray burst discovered per day. However, due to their short duration, it's very difficult to pinpoint the exact location of these bursts. And what is somewhat worrisome is that they also discover that these gamma ray bursts can occur close to the Milky Way galaxy, yet fortunately for us, this is quite rare. Models done by NASA have suggested that there's likely an afterglow following a gamma ray burst. This afterglow is thought to look like a slowly fading emission at longer wavelengths, and is created by collisions between the burst ejecta and interstellar gas. Unfortunately though, NASA has been unable to detect the afterglow effect in practice. As of now, technology has been the main factor to blame. This is because up until 1997, scientists only had the capability to discover a gamma ray burst about 20 hours after they occurred, meaning that the exact distance and location of these bursts went unknown for years. Yet that may soon change. Thanks to recent breakthroughs from GRB detecting satellites, scientists have been able to localize an event within 4 hours and follow the path accurately. This advancement has led to the conclusion that gamma ray bursts are often connected with the death of stars, or more specifically, supernovae. In fact, due to the research of afterglows, scientists have been able to pinpoint the furthest object known to mankind, GRB 090429b. Although this may come as a bit of a spacey surprise, gamma ray bursts have actually found their place in pop culture. More notably, these gamma ray bursts were used to create the Hulk in the Marvel comics. As the story goes, Bruce Banner, aka the Incredible Hulk, was involved in an explosion with gamma rays, which somehow changed his body from that of a regular human to the Hulk. Now, the explanation in the comics is that the gamma rays were so powerful that they could create matter, therefore physically changing Bruce Banner. And as weird as it sounds, to an extent it's actually true. This is because, as Einstein's formula E equals mc squared explains, energy can be converted to matter and vice versa. Therefore, technically speaking, matter could be created from a gamma ray burst. Yeah, but don't get too excited, because after that the science gets pretty shaky. For example, Dr. Banner would realistically not have been able to survive being hit by an explosion big enough to create gamma rays. After all, those explosions, as we said, destroy planets. Moreover, in the comics, the gamma rays appeared green, giving the Incredible Hulk his green skin. Well, in reality, gamma rays are colorless. Therefore, while the Incredible Hulk may be entertaining to watch, don't get your hopes up that a real-life version of him could be created anytime soon. As previously mentioned, gamma ray bursts happen quite frequently throughout the cosmos. However, we're not exactly that great at finding them. You see, scientists have recently determined that photons emitted from gamma ray bursts all flow in the same direction, but it seems that the directions are able to change over time. As a result, gamma ray bursts are able to focus their energy in a narrow beam, rather than emitting it equally in every direction, meaning that some satellites will inevitably miss some of these emissions. In fact, astronomers have estimated that there are roughly 500 gamma ray bursts daily. But as of now, we've only been able to detect approximately 1 a day. Therefore, in order to observe the other 499 plus that we currently miss, scientists are at the moment hoping to find more ways to accurately detect gamma rays. Just imagine all that beautiful data we're going to get once we get all 500 of those babies. Despite being discovered in the 1960s, gamma ray bursts weren't officially seen until 1991. This GRB was witnessed at the Compton Gamma Ray Observatory using the Burst and Transient Source Experiment, or BATSI. According to Swinburne University of Technology in Australia, once they discovered the first one, BATSI observed about 1 new gamma ray burst every single day, leading them to the conclusion that gamma ray bursts were occurring all across the cosmos. This belief is in fact still widely accepted today. Alright, you bunch of GRB heads, that does it for this one. Thanks for watching Super Freaky Science, and don't forget to subscribe.